Sliding window analytics. So, in this Spark streaming, we will see that the most important functionality is the window based operations. So, using this window based operation, we can design many applications, and also we can design many new algorithms for doing the analytics, and therefore they are called as a sliding window analytics. Some examples we are going to see in the further slides on this. What are the different applications programs we can build using this feature, which is called a window, and hence we will see in more detail about the sliding window analytics. So, Spark streaming windowing capabilities, that is, the window has window function has two parameters. The first one is called window length, which is nothing but the duration of window. The second parameter is called the sliding interval, which is an interval at which the window operation is being performed. So, both the parameters must be in a multiple of batch intervals. So, we have to see how these particular parameters we can use, that is the window length and sliding interval, and using this we can design many applications. So, a window creates a new D stream with a larger batch size. So, for example, if this is the input D stream, and this particular input D stream is divided into the batches of time 1, time 2, time 3, time 4, time 5, and this window length is 3 of 3 batches, which includes the window length is of size 3, and sliding interval is basically the 2, then obviously there will be one overlap. So, that is shown over here. So, the original D stream is shown here, which is divided into the batches 1, 2, 3, 4, 5, and when the window operation is being performed, that is the windowed D stream, which will be based on per window, this particular operation will be available. So, there will be an overlap of 1. So, that means you see that in window at time 1 there will be a window D stream will be available, and at time 3 again there will be a window D stream at time 3 will be available, and then window at time 4 this window D stream will be available. So, these particular window based sliding interval will tell that the window operation is being performed. This is the interval. So, sliding interval of size 2 will give so sliding interval of size 1 will give this kind of now Spark window functions. So, Spark window functions for data frame and SQL, so which is introduced in Spark 1.4. Spark window functions improve the expressiveness of Spark data frames and Spark SQL. With window functions, you can easily calculate the moving average or cumulative sum or reference a value in the previous row of a table. So, window function allows you to do many common calculations with data frames without having to resort to RDD's manipulations. So, aggregates UDF versus window functions. So, window functions are complementary to existing data frame operations such as aggregates such as sum and average and UDF. To review the aggregate calculations, one result is sum or the average for each group of rows, whereas the UDF calculate one result for each row. based on only the data on in that row. In contrast, window functions calculate one result for each row based on the window of rows. For example, in a moving average, you can calculate each row the average of the rows surrounding the current row, and this can be done using the window functions. So let us see this moving average example. So let us dive into the moving average example. In this example, the data set, there are two customers who have different spending amounts of money each day. So let us build the customer data frame, and all the examples are written in the Scala, and the same can be visualized using Python or SQL. So let us see the customer, and its data is given in the form of the list, such as the customer is Alice, and 2016 fifth month, and the date is given over here, and the time is also given, and the spending is given. So this is the amount of spending. Amount is given, and this is the name of the customer, and these are the dates when the customer has done this spendings. So given this particular detail, that this one, the name of the customer, a date, and the amount which is spent. So given this particular data of customers, and now we can perform the window operations on top of it to calculate the moving average of spending. So moving average, so create the window specifications, and so we have to specify the window. So the window will partition by the name, and order by the date, and the windows will consider the rows between -1 and 1. So -1 and 1 means in this window is specs, the data is partitioned by the customer, and each customer's data is ordered by the date, and the window frame is defined as starting from -1, that is one row before the current row, and ending at 1, that is one row after the current row. So the total, there are 3 different rows are considered in the sliding window. So 3 rows means that, for example, if this is the current row, then this row, then the row above this row will be the -1, and the row below this will be the +1. So the window of size 1 and -1 will require 3 rows into the window for operations. So therefore, the window frame is defined as starting from -1, that is one row before the current row, and ending at 1, that is one row after the current row. So total, there are 3 different rows are there in the sliding window. So having understood this notion in this particular statement of written in the Scala, we have to specify using window specification. So window partition by the name, order by the row, and the rows between -1 and 1. So that will specify the window operations. Now let us calculate the moving average using this particular Scala command, that is the customers with column, and moving average we have to calculate using the average of all of the customers by the amount is spent over the window specification which we have shown, and that we have to show. So this code will now add a new column which is called moving average. So moving average column will be now added in the customers table, and by applying the average function, so this average function on the sliding window, which is defined in the window specs in the previous slide. So that means let us see how 47.5 which we have obtained is that if this is the customer, its spending is 50. So before that is the row number -1 which is missing, but after this there is a row which is called 45 which is available. So the window so this window will consider 50 plus 45 divided by 2, that is nothing but 47.5. Now consider this particular entry, that is 45. Will consider this row as -1 and this row as +1. So this window will contain all three values, and they will be 50 plus 45 plus 55, and if you take this average, it comes out to be 50. So this value will come over here again. Now we will consider this third entry, that is 55. So this particular row will be -1 and the further row will be +1. So for this, to calculate the average, we require 45 plus 55 plus 25 divided by 3, that comes out to be 50. Similarly, for 25 we can see that this becomes -1 and this becomes +1. So for 25 these three values will be taken up into the window for averaging. 55 plus 25 plus 29, no, not that actually. So up to this point 25 will not be used. Why? Because it belongs to another customer. So here 45 plus 55 divided by 2, that will be the 25. So let us see about the Bob. So Bob, the previous values will be, let us see this case of Bob again. So in Bob case, the previous value is not there and +1 will be there. So only these two values will be used. Why? Because before that it is an Alice value. So 25, sorry. So its average will be 25 plus 29 divided by 2, that is 27. And similarly for this value, we will consider it as -1 and this is +1. So 25 plus 29 plus 27 divided by 3, that comes out to be 27. And for 27 we will see that for 27 it will only use -1. So 29 plus 27 divided by 2, that comes out to be 28. So this way the moving average is automatically calculated. Now this is the small number of entries that we have to see, that the window is sliding and is the moving average is now calculated and filled in this particular table. So window based function and window specification definition, as shown in the example, that there are two parts to applying the window function. First is specifying the window function such as the average in the example, and the second is specifying the window specs, that is window specification. So for the average, you can find the full list of window functions available on the this one Spark streaming functions, which you can apply. You can also apply the aggregate functions and the window functions together. For 2, that is specifying the window specs, there are 3 different components: partition by, order by, and frame. So partition by defines how the data is grouped. In the above example, it was customer. You have to specify a reasonable grouping, because all the data within the group will be collected onto the same machine. So, ideally the data frame has already been partitioned by the desired groupings. So, when you go for order by, it will define how the rows are ordered within the group. In the above example, it was by the date. Similarly, the frames defines the boundaries of the window with respect to the current row. In the above example, the window ranged between the previous row and the next row. So, all these are very much needed, and once it is understood, then the partition by and the order by together will perform the optimizations in the data movement from different cluster systems. And secondly, the frame, that is the window operations, is very much needed for moving average, and it depends upon the application how this particular window is used for that application. Now we will see another application of window based analytics, which is called cumulative sum. Let us calculate the cumulative sum of the amounts spent per customer. Here the window is specs, the frame ranges from beginning, that is the long and minimum value, to the current row, that is 0, and window specification is specs 2. We are now saying that you have to partition by the name, like in the previous example, order by the date, also by the previous, as per previous example, and the rows between the long min value 0. So, let us create the new column which calculates the sum over the defined window frame. So, the customer with the column that is cumulative sum, that is sum we have to define as function of the customer amount is spent over the window specs which we are now going to show. So, minimum value, long minimum value, and 0 we are going to show. So, Alice has spent 50. So, the accumulated amount is 50 only. Then Alice has spent 45. So, cumulative will be 95, automatically will be calculated. Then Alice has spent 55, then it becomes 150 in this case. Then Bob has spent 25, so it becomes 25. It has spent 29, it becomes 54. Then it becomes then it has spent 27, and the cumulative amount becomes 81. So, let us see that the new row which is called cumulative sum, and this will be created using this particular command. Customer with the column, a new column will be added and will be calculated in this using the window functions. Now, we are going to see the rank. In this example, we want to know the order of the customer's visit to the store, whether this is the first time, second time, or third visit. So, that is called the rank. So, rank function returns what we want. So, customer with the column, and we are going to add the rank within that particular column. So, you see the rank is added over here, and we want to rank over the window specification, and then we have to show. So, window specification, we are doing the same window specification which we have specified in the previous example. And now let us see that is the Alice, when it has visited on this date and spent 50 amount, then first time it has visited, then next day it has spent 45, then second time it has visited, and the next time it is third time. Similarly, the Bob has visited 3 times. So, as it is visiting and spending on another date, automatically the rank of that customer is increasing. Now, this kind of analysis or analytics is very much useful in many of the websites which are doing the e-commerce or doing the business, and based on for example, the first time a customer is logging into the system or doing the business with that taking the service, then as far as the promotions are concerned, using this particular information, it will give some promotional discount for the new customer to be attracted, and for the old customers this particular values are changed accordingly based on the policies of the business. Now let us see another case study of this Spark streaming analytics using Twitter sentiment analysis using the Spark streaming. So Twitter sentiment analysis, that means here we want to find out the trending topics can be used to create the campaigns and attract larger audience. Sentiment analysis helps in the crisis management and service adjusting and target marketing. So therefore, the sentiment analysis is going to become a very important thing in the web and in all businesses. And the sentiments refer to the emotion behind the social media mentioned online. Sentiment analysis is categorizing the tweets related to the particular topic and performing data mining using sentiment automation analytics tools. We will be performing Twitter sentiment analysis as an use case or streaming data. So let us see the what we are going to see here is to design a Twitter sentiment analysis system where we populate the real-time sentiments for crisis management, service adjusting, and the target marketing. Sentiment analysis is used to predict the success of a movie, predict the political campaign success, decide whether to invest in a certain company, target advertising, review the product and services. So let us go and see this particular details. So we have to follow the pipeline. This is called token authorization, and here the Twitter which are given as the input we are going to apply. And now we perform the de-streaming transformations on this Twitter d-stream, which is now captured and as the stream and given here in the system. So the first statement is about we have to start a new Spark configuration, and we have to set the Spark streaming or streaming context. So streaming context is just like Spark context. Here we are using the streaming context, and this particular streaming context we are creating the window of 5 seconds. Now this Twitter utility will create the stream, and this stream will use the Twitter utility, and this will be the input stream to the Spark system, streaming system, and it will apply some filters. Filters are none, and so all the stream will be taken up into the streaming system. Now this particular D stream will be transformed using flat map. So flat map will use the will get the hashtag entries, and it will get the text out of the hashtag entries, and this is called the tag. So out of the stream it will capture the hashtag entries. So this is the some results which we have gathered into the captured into the system, and now we are going to analyzing the sentiment of a particular politician using this. Now we are applying the sentiment analysis. As we have seen from our sentiment analysis demonstration, we can extract the sentiment of a particular topic, and we did for a politician TRUMP. Similarly, sentiment analysis can be used in the crisis management and service adjusting and target marketing by the companies around the world. Companies using the Spark streaming for sentiment have applied the same approach to achieve the following: enhancing the customer experience, gaining the competitive advantage, gaining business intelligence, revitalizing losing a brand. So these are the following references. For further details to refer the spark.apache.org/streaming, and the streaming programming guide is also there, spark.incubator.apache.org. And also we have used some of the material from databricks.com speaker Tathagat Das. Conclusion: stream processing framework that is scalable to the large clusters, achieves seconds of scale latency, has the programming simple programming model, will integrate into the batch and interactive workloads, ensures efficient fault tolerance in the stateful computations. Thank you.